if you set this up, if you draw a picture of what's going on here, side A is going to be this one across from angle A, so that's the 11. Side C is across from angle C, so that's the 14. And then angle B is right here, and that's the 34 degrees. So based on what we're given, and based on what we can now see is labeled in the triangle, is the law of sines going to work?
No.
Why not? Right. So in all the situations you saw from 6.1, we were either given a pair of angle and opposite side that we could set up one ratio for, or we were given two of the angles and we could figure out the third angle, which would then be across from the opposite side. So we could somehow get that first ratio in the law of sines to then set up what the second ratio could be with the unknown, set up the proportion, solve the proportion, get our answer. That's not possible with what we have here. So what kind of a triangle would you call this?
Equilateral.
Really? 14 and 11?
I just looked at it and then I thought it was.
Wow.
It's not actually.
Really? Do I need to label not drawn to
I
scale?
saw Sally's scale. I don't know.
Remember we talked about law of sines worked really well with ASA, AAS, and then it worked, but not really well, with SSA. That was the ambiguous case. That's the one we had to make sure we knew what was actually going on. Okay? So those three situations are where law of sine works really well. But what kind of a triangle would you call this one?
SAS.
An SAS.
Oh.
So an SAS triangle, an SAS triangle is a situation where we have to use this law of cosines. Okay? And so what does the law of cosines say? So we've got the same kind of triangle setup as we had last class. Triangle labeled with A, B, and C for angles. Opposite sides are lowercase a, b, and c. And now, the law of cosines says, if I'm only given one angle, I'm going to take the cosine of that angle, and then the side opposite that is the one that's going to go out in front squared. And so then the other two sides make up the rest of this formula. So if angle A is the one I'm given, then side A is the one out here that's going to get squared. And then that's going to be equal to b squared plus c squared minus 2 times b times c times the cosine of A, angle A. So you see the three different versions up here, not because they're different or they're doing anything different. They're just showing you what it would look like depending on which of the angles you were given. If you're given angle B, then it's going to be side B that's out here being squared. A and C are going to make up the rest. If you're given angle C, then it's got to be side C that's out here being squared. A and B are going to make up the rest. Okay? So it's the same formula. It just looks a little different depending on which angle you're either given or you're trying to find. So you can put that in your notes, and or you can put this in your foldable now under in your law of cosines section. got down? Alright, so if we go back to this now and set up our organization grid thing here. We know 11, we know 14, we know 34. Whoops, 4, not 5. Okay. So what are we going to find first, based on this information and based on the law of cosines?
Lowercase b.
Lowercase b, side b. So side b is going to be b squared equals what?
A squared plus c squared.
What are they?
Oh,
11 squared.
11 squared
plus 14 squared.
plus 14 squared.
Is that a minus?
Minus
Oh, that's a minus.
2 times 2 times 11. 2 times 11, yeah.
Is it one to
Times
be one?
14.
Cosine.
Such a struggle.
Okay, so because I know angle B, side B is the one we're going to start with. And side B becomes the one that's out here being squared, which means side A and C are the ones that are going to fill in the A's and C's here in the formula. Okay, now if side B is what I'm trying to find out, that means everything that has been substituted in on the right side. So I can just start punching buttons on my calculator and find out what b squared is equal to. Okay? So if we go 11 squared plus 14 squared minus 2 times 11 times 14 times the cosine of 34 degrees. I'm going to use my degree symbol because I'm not really sure what mode I'm in. And then hit Control Enter to get the decimal answer of that. What do you get? From doing the right side? 11 squared plus 14 squared minus 2 times 11 times 14 times cosine of 34 degrees is 7 something?
That's 1.85.
I think you've gone a step beyond what I'm asking. I just want the right side. What's the right side equal to? I don't think so. I just want the right side. I just want you to push the buttons and tell me what the right side is equal to.
61.
Okay, that's what I was asking for. Okay. Now, what a lot of you did, which is good, but here's where the common mistake is. We need to realize that when we get this 61.66 answer, that's what b squared is equal to, and not b. So we do need to go the extra step of square rooting. It's just wasn't what I was asking for yet.
Oh.
Okay, I was just asking you to crank out the right side, which is
Oh,
that
that's
61.6566 number. Now, to get the most accurate answer, instead of actually typing in the square root of 61.66 and rounding it off, use your calculator and keep the decimal. So do the square root, which is control x squared. This the square root sign is above that in the blue, right? And then do control negative sign, because that's where you have that A and S up above it, and A and S stands for previous answer. So even though you might be seeing 4 decimal places in your screen, your calculator has probably kept in its memory a lot more than that. And so if we can just go square root of previous answer, our answer that we end up with for B is going to be much more accurate than if we round it off ourselves and then try to take the square root of it. Okay, so just try to keep using the answer in your calculator as you keep working so that you end up with as accurate of an answer as you can. So now what is B equal to? About 7.9. Okay? Okay, so that gets us side B. What do you want to find next?
Big A.
Angle A, all right. How are we going to find angle A?
Use H.
Yeah, now we can go back to law of sines. Because now we have a side and an angle that are opposite of each other. So we can set up what the first ratio should be and then set up a second ratio with my unknown to solve the proportion. So now I can take the sine of the 34 degrees over side B that I just found of 7.9 and make that equal to the sine of angle A over the 11 for side A. So if we take 11 times the sine of 34 and then divide by 7.9 plus, what is that equal to? The result that you get from taking 11 times the sine of 34 degrees and dividing it by 7.9. What is that actually equal to? The sine of A. So once you get that result, because we're trying to find an angle this time rather than a side, you then need to take your inverse sine of that result. So again, inverse sine and then control negative for previous answer. And what do you get? About 51 point what? 1.3. Okay. So since I rounded off my side to 1 decimal place, I'm going to round off my angle to 1 as well. And so angle A is going to be about 51.1 degrees. Okay. So the real power of these laws is to start using them together in a problem. If you're given an SAS, you're going to have to start out with law of cosines. But once you get the answer from your law of cosines step, then you have the information you need to be able to shift back to law of sines. And that's a slightly less complicated task to go through. So that's an easier way of getting your next answer, is to go back to law of sines. Okay? And then for angle C, what are we going to do to get that? Yeah. Now we've got 2 angles, so the third angle's just got to be 180 minus the 51.1 minus the 34, and we get our angle C. And what's that end up being? 94. And again, you can take a quick look. Is the biggest side across from the biggest angle? Yes, is the smallest side across from the smallest angle? Yes, so that's just a quick little check, like, does everything fit? Did everything come out okay? Okay, questions on that? What kind of a triangle is this one?
No, A. No.
Only got sides, SSS.
SSS.
Hold on, SSS.
So if we have an SSS, where all we know are sides, that means this was 12, B 27, C 20. Can I set up a law of sines with this one? Is law of sines gonna work? Yeah, because this is another situation where I don't have an angle this time. I don't have an angle to go across any of those sides. So this is the other case where the law of cosines has to be used. So SAS and SSS are law of cosine kinds of problems. ASA, AAS, and SSA are law of sine kinds of problems. And AAA is never enough information to tell you what your triangle is. So AAA is just focus. Okay? So if we set up our grid this time, it's going to look like this. So I'm going to need to use the law of cosines to figure out one of those angles. Does it matter which angle I decide to look for first? Yes, it does.
Oh,
That's why
the
I
biggest
asked.
one. That's the biggest one.
Why should it be the biggest one?
I just remember that from last year.
Anthony's like, I don't remember much from cramming that trig in, but I remember that. He's right. We have to start with the biggest one. The reason is this. Based on what we just did in the previous example, once we figured out a piece using law of cosines, then we shifted to law of sines, correct?
Yeah.
And in the process of using the law of sines, we had to find another angle, right? So we ended up having to do an inverse sine to get that angle. What is the allowed interval for the range of inverse sine? Negative pi over 2 to positive pi over 2. Does getting a negative angle make any sense in the context of a triangle? No. So that means all of my fourth quadrant answers don't make any sense. So it means if I'm going to get a positive angle measurement, it's only going to be a first quadrant measurement, and therefore law of sines can only spit out an acute angle for me. Does that make sense? Okay? But if I'm going to use the law of cosines to find an angle, meaning that this is where the variable is going to be, and A, B, and C are all going to be filled in, then at some point I'm going to have to take an inverse cosine to find that, right? What's my allowed range for inverse cosine? First and second, 0 to pi. So first quadrant answers would give me acutes, but second quadrant answers would give me what? Obtuse, not negatives. They're just going to give me obtuse answers. Okay? So, when you are dealing with a situation where all you know are the three sides, you need to start with the biggest angle, which we know is going to be across from the longest side. Because if there's a possibility that one of your angles is going to be obtuse, it's got to be that one. Okay? If it is obtuse, which law of cosines will show us, then the other two angles are going to have to be acute, and so using law of sines is not a problem. It's going to give me the acute angles I want. Bingo, done. Okay? If it ends up that the largest angle is acute, that's fine, because it's the largest angle. So if it's acute, the two other angles that have to be smaller also have to be acute, so law of sines will still work on those as well. So we have to start with the biggest angle, because if there's a possibility for an obtuse angle, that's where it's going to happen. And only the law of cosines is going to tell us that. Does that make sense? Kind of, sort of? All right, so we're going to have to start out with angle B. Side B is the longest of the three sides, so angle B is the one we've got to look for. So that means which number is going to have to be out here first? The 27 squared. And then the other two will make up the other side. And what we're trying to find now is that angle B. So that's where the variable is going to go. All right, it's algebra. Work it out. Use your calculator. Raise your hand if you think you got an answer.
I think.
Nobody thinks they've got an answer? Really? Algebra's that bad on a Monday morning? Chris, what do you think you got? 112.67. Raise your hand if you agree with Chris. Aaron, what'd you get?
I didn't do it right, so I got undefined.
You got undefined.
Oh, yeah.
Anybody
Yeah.
else get an undefined?
I got
Dude, you didn't use
solve.
What happens if
Also,
you're
you
getting
didn't use
undefined?
Oh,
Anybody
that's
know
why
what
it's not
you
working.
did incorrectly?
Oh my god, that's why it's not working.
Let me see if I can guess. Did you
False.
take 12 squared plus 20 squared minus 2 times 12 times 20 and then take 27 squared and either subtract it or divide by it or whatever? Anybody do that? Why can't we do that? Because this part right here is getting multiplied to cosine B, which means I cannot subtract it from the 12 squared plus the 20 squared until I have multiplied it to cosine B first. Okay? So if we add these two together, I mean, if you're doing it more step by step, 12 squared is 144, 20 squared is 400. So we're talking about 544 right there, right? Not including the 2 times 12 times 20 cosine B, okay? 27 squared, anybody got that real quick off the top of your head? Or out of your calculator?
729.
729,
That's cool.
okay? So your first step is to subtract the 544 and only the 544. That means this is going to end up being 185, and this is going to end up being a negative 480 cosine B. Which means my next step is to do what? Divide by negative 480. We're not adding and subtracting that piece. We're going to have to divide it because it's being multiplied to cosine B. So we end up with the cosine of B being equal to a negative, what was it? Anybody got it?
37/96.
Yeah, so you can simplify it. You can just put it in that way. You can get the decimal equivalent, whatever you want to do. I think as a decimal, whoops, hello, come back. As a decimal, it was a negative 0.385 or so. Okay. If you got an undefined, what happens at this step is that you've got a cosine of B that's equal to something that is either bigger than 1 or smaller than negative 1. So when you go to try to take inverse cosine of it, the calculator's like, what are you doing? You can't do that. That's why it tells you undefined.
It
It's,
says false.
false. What are you doing, ding dong, Okay?
That's right, because I would have failed all my physics tests without that.
Alright, so at this point now, when you take the inverse cosine, we're going to get an obtuse angle because this negative answer means we're in the second quadrant. First quadrant's positive, second quadrant's negative for cosines. Right? So the inverse cosine here ends up giving us this obtuse angle of, what was it, 112 point, make it 7? Okay. So with that one actually being obtuse, it's guaranteed A and C have to be acute. And so now when I set up a law of sines problem for either one of those, the fact that it's going to spit out an acute answer for me is fine. Because that's what I need. I need A and C to be acute. So now we could set up something like the sine of the 112.7 over 27, and now make that equal to the sine of A over 12. Now it doesn't matter. A or C, whichever one you want to do next, doesn't matter because they're both going to be acute. Setting up law of sines will work. It doesn't matter which one you do. Okay? And then once you get that, then finding the other angle is again just a matter of subtracting from 180. Okay, so just to finish this out, we're going to take the sine of 112.7, take that times 12, divided by 27, and then take inverse sine of that, 24.2. Does that sound right? Anybody else got it? Yep. Okay. So 24.2 here. And then finally, angle C should be what? How much? 43. Or 43.1 based on my calculations. Just depends on kind of where you're rounding. And remember, as far as rounding, just keep it consistent. 1 or 2 places is fine. If you go 1 place, do everything 1 place. If you go 2 places, do everything 2 places. Okay? So those are the 2 situations where the law of cosines is going to be your first step, and then you can switch back to law of sines once you find that first piece. SSS and SAS. Questions on using either one of those? Finding the side or finding the angle? All right, so I mentioned a few days ago, last chapter, there were a couple of problems that we saw that I said at the moment this is the way we have to do it, but we're going to come back to these later, and I'm going to show you another way that we can do it then. Today's the day. So here's one of them. This was one that we did in the lesson 4.8 notes. Kind of remember this problem? Right? So we've got this ship leaving port at noon. It heads due west at 20 knots or 20 nautical miles per hour. At 2 p.m., the ship changes course to north 54 degrees west. Find the ship's bearing and distance from the port of departure at 3 p.m. So at the time we did this in chapter 4, all we really had to work with was right triangles, right? So we set up the right triangle over here, and then we found a bunch of pieces over here first before we could sort of expand to get over here to what we wanted to know. But now that we have law of sines and law of cosines at our disposal, what would be another way to solve this? I want to know the distance the ship is from the port. Port is A, right here. So I want to know the distance that the ship is at 3 o'clock, and then we're going to figure out the bearing from that. Law of cosines with what information?
The 90 plus.
Yeah, so I can make this angle right here now 90 plus 54, which is going to be a 144. And then I've got the side over here as being 20, the side over here as being 40, so I've got an SAS kind of situation. So I don't have to go through all of the mess of finding the right triangle over here now. I just need to set up a law of cosines to figure out what C's got to be. Okay? So we start to see here that when we don't automatically have right triangles going on, that law of sines and law of cosines are huge time savers. Because we don't have to try to make them work and figure out, well, if this was 90, then what's the rest going to be and all that stuff. It's like, just go with what you've got. So we'd be setting up a c squared being equal to 20 squared plus 40 squared minus 2 times 20 times 40, and then taking the cosine of the 144. Okay? Once you get that answer, that's going to be C, so that gives you your distance. Then how would we get bearing from port to the ship? Yeah, law of sines, because then we'd need to figure out, well, what is this little angle? So that I could figure out how far did I go from north to get to that path. So once I figure out what C is, then I could set up a law of sines to figure out this one, and then figure out the bearing from there. Much easier than the whole right angle stuff that we did when we saw this the first time. Okay? So that's one example that we've seen before where law of sines and law of cosines can make life easier. This is another one. This was one from your chapter 4 review. So we're told that from city A to city B, a plane flies 810 miles due east. So this is A, due east to city B, 810 miles. Then from B to C, the plane flies 570 miles at a bearing of north 20 west. So if this is north, we went 20 west, looks something like that. And that's supposed to be 570 miles.
Not degrees.
Okay? And so then it says the pilot now wants to return to city A, and we're supposed to find the distance and the bearing that the pilot should set. Okay? So if we know that this right here is 20 degrees, then what's this got to be? So now do you see how law of sines and law of cosines can make this a whole lot easier than what we did in the practice, in the review? Now I've got another SAS. I know these two sides. I know the angle in between those two sides that was created based on the bearing that I was given. I should be able to figure out what this length is. Okay? Excuse me. So this time we'd be going side B being equal to 810 squared plus 570 squared minus 2 times 810 times 570 times the cosine of 70 degrees. Okay, and then once we find that distance, I'm assuming you can do the algebra, that's why I'm skipping over this part because there's one more thing I want to talk about quick. So once we find this distance for side B, that's how far it's going to take him to get from C to A. Now what's the bearing that he should set? That actually kind of goes back to this idea of if this is 20, then this has got to be 20. Right there. We could also then figure out what this entire angle is by now setting up a law of sines. And so if I know that part of it's 20, then I can figure out what the rest of it is by subtracting, and I can get my bearing. Right? So law of cosines to get the missing side, law of sines to get an angle that we're interested in, and then knowing that if that's 20, that's got to be 20, so whatever this bearing is just going to be the difference. Okay? So, a couple of problems we've already seen. We know that we can set them up with right triangles, that that's possible, but certainly law of sines and law of cosines make things easier. So you're allowed to use those things now if you see these kinds of problems in your near future. Last thing I want to talk about real quick. Finding the area of a triangle. So this is a third section that you can label on your thing. So you've got law of sines, law of cosines. So this next flap under your law of sines, you can put area of a triangle. And there's these two formulas that you can use when you don't know the height of the triangle. Right? Normally, we know that area of a triangle is equal to 1/2 base times height. But we also know that in any given triangle, our height has to be something that is from one vertex perpendicular to the opposite side. Well, sometimes you don't get that information. So you don't know what the height of your triangle is. So these are two other options of how you can figure out area when you don't know height. Okay? The first one doesn't have any particular name to it. And it works in any case where you have at least one angle. One angle, two sides. Okay, so sometimes you might have to use some law of sines or law of cosines to get that information. But if you have one angle and the two sides that make that angle, this will work. So if I have angle A, then I need sides B and C. And I take 1/2 times B times C times the sine of A. If it's angle C that I have, then I need sides A and B. If it's angle B that I have, then I need sides A and C. Okay? So that's going to work a lot of the time. The only time that doesn't work is if you have an SSS. Because again, you're not going to be given an angle if you have an SSS. So there's a particular formula for SSS called Heron's area formula. And with this, you have to first find this piece called S. And the way you find S is to add up your three sides and divide by 2. And then from that, we're going to take the square root, and we're going to take S times S minus A times S minus B times S minus C, square root of that whole thing. That'll give you the area of your triangle. So again, we're not going to have a lot of problems where you need to use this, so I'm not interested in you memorizing these formulas. These are formulas you can just put on your third section in your foldable, and just know when to use them, how to use them, when those problems do show up. And you'll see a couple in your homework. Okay, so just as a quick example, make sure we've got this figured out. Oops, I turned it off. How'd that happen? Hello. Seriously? Battery. There we go. So if you want to find the area of a rectangular lot having two sides of length 90 meters and 52 meters, and an included angle of 102 degrees. Which formula would you use? Option 1 or option 2?
Option 2.
Hunter doesn't sound real sure. Anybody want to help him out?
Option 1.
Option 1? What tells you that option 1 is a formula that's going to fit? Because you're given an angle, and it's an included angle. So you already have what you need to set up the formula for option 1. Okay? Because of this right here. It's an included angle of 102 degrees. If it wasn't, then you would have to go through some work with law of sines or law of cosines to find out the included angle. Okay? How about the second one? You want to find the area of a triangular lot having sides of 43 meters, 53 meters, and 72 meters. Going to have to get Heron's first. What's S going to be equal to in this case?
33 plus 72 divided by 2. Which is 84.
84. Okay. So if we get an S value of 84, then our formula is going to look like this. Square root of 84 times 84 minus the first side, 43, whoops, times 84 minus the second side of 53, times 84 minus the third side of 72. That's what you're going to work out. Okay, and just crank that into the calculator, but that's how you're going to set it up. You find that S value first, and then it's S, S minus A, S minus B, S minus C. Take the square root of the whole thing. Okay? All right, so homework for tonight is going to come mostly from 6.2. I am going to have you do a couple of problems from 6.1. because I want you to do a couple of the area problems with the option 1 formula, and that's actually came from 6.1. We just didn't get to it last class. So there'll be a couple of problems from 6.1, mostly from 6.2. I will get it posted for you in 15 minutes once you all leave and I have a prep period. I'll get that posted on Canvas so that you know what to work on. I'll also get the 6.1 class lesson posted on Canvas for those of you who missed it. And next class, we will have a quiz just over law of sines, law of cosines. Okay? So, make sure you have those 3 things, law of sines, law of cosines, and the area formulas filled in on the first 3 sections of your foldable, because you'll be allowed to use your foldable on the quiz. If you don't have it filled in, it's not going to help you. You're going to have it in your head. So make sure that that's all filled in on your foldable, and you've actually got about 7 minutes right now. So if you want to go back and make sure that law of sines is filled in correctly, so that you've got your foldable all set up for today, you could use the time to do that, and then you'd be ready to go for homework and quiz.
So the homework they do is